Welcome back to another episode of Let's Talk Security Testing, the podcast where we talk all things security testing. Today we are deep diving into a specific vulnerability. It's the first time we've done anything like this on the podcast, so stay with us. We promise to make it interesting. The vulnerability up for discussion is business logic flaws. So I guess let's just define what it is straight up. What is a business logic flaw?
A business logic flaw is it's a kind of vulnerability where instead of there being broken code, for example, the code is completely fine in principle, and as far as the machine is concerned, the code is doing what it's doing. It's more a flaw in the rationale or the concepts behind what that code is then able to do. So, for example, a classic business logic flaw that people talk about all the time comes from checkout systems for e-commerce websites, right? You go on and you go to buy a t-shirt from an e-com website, and that t-shirt is £10. But when it comes to the checkout process, instead of buying one, you put a minus in before that one. The logic behind the code is if it's 1, then it's £10. If it's 2, then it's £20. And therefore, if it's minus 1, it becomes minus £10. And all of a sudden, you're in a situation where the code's doing what it's supposed to be doing. It's multiplying by the number of the resource that you're trying to purchase. And subsequently, you might get refunded £10. Another example of a business logic flaw is actually one that we experience internally, and I can speak on hopefully we can discuss a little bit more inside this, and that is in permissions management systems. So we found a business logic flaw in a staging version of our application after asking a developer to update our permission system so that users could alter the permissions of other users. The idea being that administrators could grant a user administrative privileges. They didn't just have to configure it when the account was first set up. Afterwards, they could escalate that user's privileges. The problem and the business logic flaw was that because we'd failed to consider whether or not a user was an administrator to begin with when they were granting those permissions, effectively that meant that users could grant themselves permissions above the level that they were currently at. They could start escalating their permissions through an intended functionality within the application, but with an unintended consequence.
Intended functionality with unintended consequences. It's a good way of summarising them, isn't it? Okay, so what do we need to understand about business logic flaws? Why are we calling them out? What makes them unique?
There's a lot of things that make them unique. The first one is that they require you to have an actual consideration for the context, right? You need to actually understand what the intended functionality is and the intended outcome is so that you can understand when something is not doing that. Security testing is all about making a system do a thing other than what it was intended to do. But this is a specific example where you need to understand deeply what the rationale behind the functionality is in order to identify it. And that comes with some unique challenges, right? We talk about this all the time, the fact that lots and lots of vulnerabilities are kind of a Boolean true or false. The vulnerability is there if this thing is present. The vulnerability is not there if the thing is not present. And therefore you can scan for them, for example. With business logic flaws, it's in one application, it might behave that way, and that might be exactly what you hoped it to do, and therefore it's not a business logic flaw. In another application, it might behave in the exact same way, but you don't want it to do that, and therefore it is a business logic flaw. So what are your take on the challenges around from that and finding business logic flaws?
Largely having, organised thousands of tests, I think, over the decade long I've had in this industry. What I find really unique about logic flaws is that when you do a pen test, particularly of an application, and you find, say, 10, 15 vulnerabilities, if there's a logic flaw contained within those 10, 15, you can damn well be sure that it'll be the first place the customer's eyes go when the report gets delivered. And the reason for this, to your point earlier, is largely that scanners aren't very good at finding these things. Why is that important? Well, that's because the customer's already running scanners. So typically, in most pen tests, a number of the vulnerabilities discovered the customer will already be aware of, right? That's just, par for the course. There'll be things that they've deemed to be less important, there'll be risks they've accepted, but they'll still be there and therefore they'll still get reported. But with logic flaws, more often than not, when they come through, the customer goes, oh, and all of a sudden, all the value of pen testing is suddenly there for all to see. In a post-test wash-up call, for example, because of the beauty that is this logic flaw that they wouldn't have known about had they not spent X thousand pounds on this test. So my experience of them is they're pretty good at getting people to spend more money on testing.
It's interesting actually you say that, because I think it's more than just that. That is a good merit for pen testing. But one of the other contradictions of business logic flaws is the fact that while they are really hard to find, and especially by automated tools in a lot of cases, and we should definitely touch on that more, they're also, I think, one of the kinds of vulnerabilities that everybody conceptually gets pretty quickly. When you start talking about SQL injection or you start talking about cross-site scripting, most people's eyes will gloss over, like they're not particularly interesting if you're not interested in web application vulnerabilities. When you say, I was able to order -1 t-shirts and the site therefore refunded me £10, it's kind of like everybody kind of gets, I can kind of see how that happened and it's actually quite interesting.
Yeah. Or worse yet, testing a banking system and, I managed to convert $1 million into $1 million some other currency and somehow exfiltrate the exchange rate to whatever I wanted it to be. These things can be, really, really significant. More often than not, and I guess this is to your point, business logic flaws are really common in bug bounty programs.
Yeah, I think nobody does a bug bounty program, or hopefully nobody does a bug bounty program until they're relatively confident that they picked off the low-hanging fruit. Because if you've got a budget behind your program, you've got a £10,000 or £100,000 pot, whatever it is, to pay out to the bounty hunters. You don't really want to be paying them for HTTP headers and ciphers and the kinds of things that you can click a button and find out about in 5 minutes. So it's only really the vulnerabilities that require somebody spending some time, some thought, and applying some real methodology to being able to find. Business logic flaws, that's the definition of them. As we keep sort of saying, the automated tools are not going to find them because the automated tools don't understand the rationale and therefore they're not able to do them. And I say that to be fair. There are ways that you can use automation to help you find business logic flaws, but there will always be a person needed to be in the loop to be able to actually validate it, confirm it, and be really confident in it. Yeah.
Another, again, just to further add, just because I think it's cool. There was a high-profile, I don't know if you saw it, I think it was a couple of years ago now, there was a really high-profile bug bounty finding, and it was between, I think it was Meta's program, but it was all to do with the merging of Instagram and Facebook, and the ability to be able to log into Instagram as a Facebook user. I can't remember the intricacies of the vulnerability, but effectively it was basically just dancing around the login functionality to be able to reset one's password in Instagram and then be able to use that code in Facebook. And what it effectively allowed us to do is a completely unknown person. I think all they would have needed is the email address and the password. They didn't need the multi-factor. They didn't need the multi-factor code, which obviously is generally speaking, if you just need a username and password of a Facebook account, you can probably get a few of those fairly easily off the dark web. So these things can be really damaging. And I guess to your point before, instances like, for example, where you're trying to merge two systems to talk to one another, large development projects, sprints that involve authentication windows, sprints that involve checkout systems. I take it there are certain types of changes that would lend themselves more to introducing business logic flaws than other changes.
Yeah, I mean, absolutely. If you're changing the copy on a website, for example, you're not going to introduce any vulnerabilities at all. Certainly not business logic flaws. But if you're doing something like changing the authentication flow, as the example you've just given, then that's the kind of time where you've got real opportunity to introduce those kinds of flaws. Typically, business logic flaws come from instances where you are changing the user journey and the user flow within the application. Not all the time, but it is typically where there are multiple steps, because a lot of business logic flaws come from those steps either happening in the wrong order, or they come from one of those multiple steps. You're not quite considering all of the available directions that a person could go from that point. Similarly, there are lots and lots of changes, like if you're just going to be introducing a new parameter for data entry, classic CRUD operations, those sorts of things, you're probably not going to be introducing a business logic flaw. So it's really, really interesting looking at the kinds of changes that businesses are making and doing statistical analysis. It's something that I've spent a lot of my time doing to be able to figure out specifically which vulnerabilities come from which specific changes. So authentication flows, checkout flows, the permission management flows, and sort of general onboarding, offboarding. Those are all areas. And the other one, inventory management. A lot of applications that do some level of stock management or altering of stock levels. Those are all the areas that I would be thinking business logic flaws are the first thing that I'm going to look for here, because these are the places that you typically find them.
So, hold on a second. If manual testing largely is the primary vehicle for finding business logic flaws, and we do vulnerability scans every week, day, month, whatever, does that mean that we simply are just looking, missing gaps like business logic flaws in our everyday testing, and therefore only look for them once every year, twice a year, once every 2 years in some occasions?
This is one of the sort of unspoken truths of relying on scanning as your primary method of finding vulnerabilities. Scanners are brilliant at finding 80% of vulnerabilities, and bad or entirely incapable of finding 20% of vulnerabilities, and business logic flaws snugly fit inside that 20%. It is the reality that if you are pumping out a new feature or a new functionality every week of the year, and one of those functionalities introduces a business logic flaw, you are not going to find that vulnerability until somebody comes in and reviews that change.
But this can't be right. I've been told by an industry for 10 years that scanners provide coverage and pen tests provide depth. Are you telling me that that's not true?
I'm telling you that scanners provide a breadth of testing for a specific number of vulnerabilities, and that people provide the testing for the vulnerabilities that those scanners are unable to find. I don't think it's been particularly well defined in the past. We're working on at the moment a way of being able to help contribute towards a definition for which for which detection methods are needed to find each kind of vulnerability. People have always said exactly what you said, but the reality is that what we really need and what we would really benefit from is a way of being able to say, okay, so these vulnerabilities, they're covered by the scanners, we're comfortable with that. These vulnerabilities, they need a person to step in, and we need a mechanism for being able to decide when to bring those people in, what to tell them to test for, and then a mechanism for saying these other things, they're comfortable and they're covered.
I wonder how common it is, and I guess the people listening will be able to answer this better than we can, but I wonder how common it is for people to actually, when they buy a security tool, to take a list of the CWEs that could exist on their system, right? A good example here is if you don't use SQL databases, you're probably not going to be vulnerable to SQL injection. So so taking a look at your sort of wider threat model, I guess, of all of your systems, of what vulnerabilities could technically exist there, and then looking at your tooling and saying, what are these things good at finding? And then looking at that gap, how often do you think that exercise is performed when we're picking tools to match our environment, or do we just pick tools? Usually?
Oh, I mean, never, right? Unfortunately. I think the way that people mostly compare tools is by comparing them to other tools.
Yeah.
You know, you say...
And the scanning companies don't make this easier anyway. It's not like they typically publish a list and says, this is what we do really well and this is what we don't do.
No, and they're all competing against each other. So, yeah, you take 5 different scanning technologies and you scan them against the same application and you say, okay, this one found 9 vulnerabilities, this one found 10 vulnerabilities, and this one found 15. I'll buy the one that found the 15 vulnerabilities, and nobody really stops to question, okay, but there are 20 vulnerabilities in this application. What am I doing about the others? But like I say, the problem is that research hasn't been done. You know, we are working, and actually we're working in collaboration with a university at the moment on a project to be able to actually establish this and define it more clearly. But I don't think this is a secret of the scanning vendors. I don't think this is something that they sort of are trying to hide or anything like that. I think it's just been poorly defined.
Yeah, no, I couldn't agree with you more. So how do we fix this? How do we look at business logic flaws differently when we're running a security testing program?
I think the way to look at it is to we talk about gates in security. We talk about establishing the various different gates that something has to go through to be qualified as suitable for release, right? A lot of organizations look at it as like the first gate might be SAST, the second gate might be DAST, and then the third gate might be penetration testing. And lots of organizations have accepted that as long as it passes those first 2 gates, then that's a suitable level of risk management to be able to deploy it to production, and for it to be in production for a while before that pen test comes in and establishes. And as long as you're going through that final gate at least once a year, then that's probably fine, a lot of organizations kind of believe. What my argument is instead of treating this as a single linear path, what we can actually do is start looking at, for each change that you are making, considering if there is a different path, a different workflow that you can work through that's more specific, more customized to that particular change. Like I said, there are particular changes that will introduce business logic flaws, and so maybe those changes are ones where you should be passing through, a SAST and a DAST gate, but you should be passing through a gate that says, test this particular change for business logic flaws. In a similar way, and it's not just business logic flaws, in a similar way to if you're introducing a new form field or a new database query or something of that nature, you should probably be passing through a gate that is specifically designed to be able to detect SQL injection flaws, for example. Yeah.
So what you're saying is we effectively need to threat model a change, ideally to arrive at a list of potential vulnerabilities. What could we be introducing when we typically make this change, and get that list. And then I presume then looking at our tool sets and saying, okay, what of our existing security tools we have, how proficient are they at finding the vulnerabilities from this list? Quite simply, check them off if you need to, look at these things. And then of the ones that are left, assumedly then we need to get a human to look at those things, and based on the skills we have internally or external vendors at our disposal, we can then to do that. That sounds like quite a lot to do if we're releasing twice a day.
Well, there's an easy, there's a medium, and there's a hard version of being able to do this, right? The easy version of being able to do this is to not necessarily have to threat model everything. You define specific classes of changes that if you're making go through a specific sequence of actions, a specific playbook that you can orchestrate. So if you are touching the authentication flow, for example, then it needs to pass through 4 or 5 gates, and one of those gates includes testing for business logic flaws. And then if you've got those, like that small number of different playbooks, then you can just pick and choose which playbook to orchestrate depending on the particular change you do. That is the simplest to do, probably the most sort of expensive, costly, and unscalable in the long run, but certainly good for a lot of organisations that don't necessarily need to operate at a massive scale. The sort of the medium way to be able to do it is that you start reviewing those tickets and doing a bit of a threat modelling exercise against them, and picking off again the ones. And you don't have to do this yourself manually, right? You can use things like large language models to help support you in this and analyse those tickets and say, this ticket has the potential to introduce these 4 or 5 vulnerabilities, and if it flags that, then to pass it through those same playbooks and those same gates. And then the harder one, that is certainly the one that's going to be the most efficient, the most scalable, and I think give people the most confidence, is effectively apply the same logic, but instead of using a playbook, you actually build out custom playbooks for each and every single change, so that you're always passing through the gates that always cover all of the vulnerabilities that you have the potential to introduce for each individual situation. So you threat model it using either manual effort, or, as I say, you can use automation in order to facilitate that. You pick and choose from all of the available testing actions to orchestrate, manual and automated, and then you make these hyper specific playbooks that are designed to catch every kind of vulnerability.
Sounds like a great use case for AI.
Yeah, I think we've talked a lot about the idea that AI is the opportunity to be able to do things that at the moment we do not have the capacity to be able to do. It's not an infallible technology. It will make some mistakes in certain instances. But if you've got 10,000 tickets being processed through your SDLC every week, then obviously this is not something the businesses have ever been able to believe that they could possibly do. But it is certainly something that these days we know actually do have the opportunity to start having a shot at.
Yeah. Make a custom testing plan off the back of a dynamic threat model as a result of a ticket or a change. I mean, the logic's there, and it's not trivial, is it? I mean, it's trivial. It's in theory, there's widely published. A decent security person can look at a change and write that threat model, and you're just then at that point comparing a threat model to a known list of detection methods, which is published on the MITRE website. Patchy, but that research is developing. As you say, we're contributing towards that as well. Not something that AI would typically struggle to do, right? We're not asking it to think. We're not asking it to write a sales email. We're asking it to pull from a big piece of information, but just pull from that information and make decisions based on that.
Exactly, and then it comes back to exactly what I was saying before. This is a perfect example of how you cannot automate the detection of business logic flaws, at least not yet, but you can use automation, and you should and you need to use automation if you're going to stand a chance of consistently finding business logic flaws before they reach production.
Yeah, sure. Well, I think that's just about enough of business logic flaws. I hope everyone listening has stayed with us for the whole time. It's definitely not the most exciting title, but I hope we did it justice. Any takeaways, Tom, before we close out?
I think business logic flaws are the best place to catch business logic flaws is before they've even reached production. So certainly have a conversation, have a consideration, and think about whether every single step in your user journey has been considered, and the kinds of ways that people might be able to manipulate things are considered. But things will slip through the net, and when they do, obviously you can't just rely on automation in order to catch all of them. And traditional scanning technologies, you can't necessarily rely on those for business logic flaws. So consider whether or not the gates that you've currently got up are adequate, or whether or not there are mechanisms that you need to introduce to be able to confidently and consistently catch these kinds of vulnerabilities.
Awesome. Right, well, thanks everybody for listening, and we'll be back with you in a couple of weeks for another episode of Let's Talk Security Testing.
Bye now.
That's a synchronized bye now.